Okay, welcome to our last class for the circles unit. We'll just be going over the final review. The first thing we need to do is record. Tell you how many marks it will be worth and which questions you're doing specifically. I decided to focus mainly on the diagram questions because when it comes to geometry, that's what's important. Can you work with a diagram? Can you work with a blueprint? Circles. Final review. Yes. First ones are on page 425. Those are going to be numbers 1 and 2. Second ones are on page 426. Those are 5 and 7. And third on page 427, 10 and 12. There's a wealth of questions to choose from. So these are the ones that I picked out. And again, I focused on the diagram questions. And this review will be worth 20 marks. Right, so let's go over each of those questions. First of all, okay, there's my no longer frozen, so we can go ahead. Some of this stuff is going to seem crazily easy after the more recent stuff we've been doing, especially 1 and 2 here. Point O is your center, find X and Y. You might notice that this is inscribed into a semicircle, and then it becomes obvious what X is, and you can simply proceed to find Y. Okay. You want to find Y, A, and B for each one. In this case, you're only finding X and Y. Over here, again, inscribed into a semicircle, this is a right angle, so you can easily find Y. And then you want to find side A. You got to use Pythagoras. You know the long side, so naturally you'll be subtracting. Okay? Looking here at 1C. Again, we've got some cool stuff going on. We've got a couple of radiuses. They're inscribed into a semicircle. So we can simply, once again, use Pythagoras. If this guy is a radius and it's 9, well, then this guy is also a radius. So this has to be 9 as well, obviously. So then you have the two sides that are 20 that go on top of each other. So you have 9, 9, and 20. And then you can easily use that to find A and B. Just a quick, the right angle is over here, right? And here. So the 20 is your long side. When you're doing your A squared plus B squared equals C squared. 20 is going to be C. Just a little tip there, because this diagram is a bit, sometimes they make them a little trickier, right? So a bit of a tip there. Here we have, we're trying to find, let's read this. A circular mirror is suspended by a wire from a hook H. So that's here. Point O is the center of the circle and is 16 centimeters below H. So this is 16. Explain how you know that the wire is not a tangent to the circle at P and Q. So how is this wire not a tangent? What is a tangent? If you don't remember the exact definition of a tangent, go back to the definition, then come back here. Take a look at this, and you will see why it's not a tangent. This is more of a written explanation type of question, and really, one of the things I could really do is give the answer. Don't want to do that. There's really no particular hints I can give. Go back, check the definition if you don't already know. We'll call it a conference or a shot because I have some students fooling around. And we'll just shut it off. Someone turned the mic on, not knowing that their chit chat's going to be winding up on YouTube. Yeah? But we'll soon shut it off here. In fact, I've shut it off permanently. All right, continuing on then. That's number 2. We just talked about number 5. Point O is the center of the circle. Determine each value of x. Well, what do we got here? We've got a perpendicular bisector coming down here. We've got the full length here, that's 10. So you take half of this. That'll be one side of the triangle, and then this is an 8, and then you can use you know what to find x, right? Here we want to know x down here. So let's look at what we have to work with. We have got a diameter of 16. We have this guy that's 7. So if we were to go, I like a pencil here. I got one. Go like this. You've created all of a sudden a nice right triangle, and this is a radius that's coming from the middle all the way to the outside. So if the diameter is 16, the radius has to be 8. And then it becomes relatively simple. You can find this unknown side of the triangle down here using our tried and true method. And x that we're trying to find will be equal, because this perpendicular bisector plus, look at the 2 equality symbols right here. There you have 5a and b. Let's flip over to number 10 on page 427. So the more recent concepts now. Aha! Point O is the center of the circle. Determine each value of x and y. Justify your answers. Well, this is inscribed into a semicircle. It's probably the easiest question in the entire review. So x and y have to be da-da-da, do-do-do, the semicircle concept, anyone? B. Here we have 120. And this is the central angle, and this is an inscribed angle. You know, good old doubling, right? So this is going to be half of this. Then we come all the way around here. These two angles are inscribed by the same chord. X and y got to be equal. So once you use the concept to find out what x is, y naturally follows. It's equal. It's inscribed into the same chord, the same arc of this circle. Remember that idea? 10C. Here we have a 150-degree central angle. We can use that to find out what y is, can't we? Yes, we can. So we use that to find out what y is. I'm not going to reiterate how to do that. I think you know it by now. Let's talk about x. Notice this is the center of the circle. So this guy here is a radius, and this guy is a radius. It's a circle. They have to be equal. We have an isosceles triangle, and we know the measure of the big angle. The other two got to be equal. Boom, boom, we got it. Right? Right. And our last one, number 12. So number 12 actually begins down here, but the questions are right here. Here's 12a. Each time we're finding the measure of x and the measure of y. Y, oh y. So, do we have any opposite angles that we can work with here? Well, these two. These two are inscribed by the same chord, right here. But we don't have the full angle, so the full angle here would be a 70. Yes. Okay, so we could use that. So here we have a couple of 70s, because they're coming around. I gotta think about this one. Gotta think about this one for a bit. Let's do the easy ones. Let's do B. 85, so this is opposite. It has to add up to 180. 68. Again, adding up to 180. C, I think C is easy. Let's have a look. Oh yeah, we want this central angle here to double to find this one. We have the circle, so this guy's 140. 360 take away 140 will give us this guy, and this guy will simply be half. So those were easy, but let's have another look at A now. Now that I've redeemed myself and proved that I can actually do this stuff. 105. 105, and therefore, if I'm going across, this should add up to 180. So here, then, we don't have a 70, we have a 75. Like these two, the corner of the quadrilateral here is a 75. Can I use that information to find y? I'm not sure at this point, but we'll keep working with it, won't we? This triangle here is a 70. Okay, 425. I have a suspicion about this question. I'm just going to check it. There's something. Page number again, 425. The review, number 12A. 20 and 55. Oh, I think I get it. I get it. It's not hard. It's easy. Here we have the angle here, and that means this angle here is going to be double what this one is. Is that right? No, forget it. We're going to scrap the question. I thought for a second, no, there's an error here that doesn't quite, like this should be, we should be able to take half of this and get this, but this should be double this, but that would be 210. There's no way that can be a 210. It doesn't make any sense. 210. No. It just doesn't make any sense. It cannot be a 210. There's something not right about this diagram. We're going to leave it at that. So let's go back here and just be aware for number 12 to do B and C. Number 12, B and C, not A. Yep, there's just something that does not quite jive about that diagram. And I checked the answer key, it still doesn't. It just does not quite. Anyway, good. We're going to skip it. We're going to skip A. We're going to do 12, B and C. So once again, 1 and 2, 5 and 7, 10, 12, B and C. That's it for this very brief